Hello, this is the effects on African clogged tadpoles using palmitic acid. This research was done by myself, Sydney Horniker, Daniel Danowski, Alex Gervais, and Dr. Jennifer A. Firestein. As an introduction to our experiment, it has been noticed that in North America and nearby ponds and lakes, that tadpoles had been dying. It is hypothesized that the honeysuckle leaves are falling off and into the lakes and contaminating the water with the chemicals found on or within the leaves. In previous studies, leaves had been extracted using ethanol and ran through gas chromatography and mass spectrometry to determine the compounds within the leaves. Over here we have the mass spec of the extracted leaf samples, and then we zoomed into 18.82 to get the spectra here. We found a reverse match of 582 on N-hexadenoic acid, which is better known as palmitic acid. This was also found within most of the leaf samples that were taken previously.
And my name is Danielle Danowski. For the routines of this experiment, we recorded each tank for 5 minutes. 5 minutes on the aerial view to get horizontal movement, and then 5 minutes from parallel view to measure vertical movement. The tanks were placed on a 1x1 inch grid. To measure their movement, that grid was on the bottom of the tank and on the back. And the data that we got from that is our activity rate from the top view was very random. There was no consistency with it. And then on the side view of the tank, there was a continuous peak on the first day, and then it ended up mellowing out towards the end. And we're assuming that this is from the tadpoles acclimating to their new environments. And then our growth rate that was measured is we would take the tadpoles out with a net, place it onto a clear petri dish, and have a metric ruler underneath them and measure from their mouth to the end of their body, and that does not include their tail. And from that, we got this graph. And you can see a consistent growth in many tanks, especially the control tank, showing the highest growth rate. And some tanks, like the 500 picoliter, did show a decline, but that is because of a frog death that did occur, and the average did change. And then we have our feeding schedule that was the amount of 0.007 grams, give and take 0.005 grams of Xenopus tadpole food that was soaked in 1 milliliter filtered water. And then our mortality rate through our whole experiment was we saw a total of 2 deaths from amounts of palmitic acid for 500 picoliters on day 5 and day 15. And we saw 2 more deaths from the tanks containing 0.195 microliters on day 7 and 10. And we also saw another death on the control tanks on day 14, so it showed no consistency with palmitic acid and mortality rate.
Hi, my name is Alex Gervais, and the conclusion of this experiment is that, however, the activity rate and the mortality rate not being affected in the tadpoles and not showing any results due to the palmitic acid, the growth rate, however, did show at least some bit of a change due from the control to the tanks affected with the palmitic acid. Showing that the tank that had the control in it was growing at a more steady and constant rate than the tank that had the palmitic acid in it. The tank that had the palmitic acid in it was growing at a slower rate and also was beginning to plateau a lot sooner than the control group, as the control group was growing at a normal and constant rate and never quite had a plateau and was continuously growing, and by the end had legs by the end of the experiment.
Good shit.